Hello class, welcome to our last lesson dealing with section 3.4, linear and angular speed. Remember today's questions deal with the fourth day's worth of material. I thought we'd go over questions 1, 2, and 3. Questions 4 and 5 are ones I'd like you to try it on your own. This is an angular speed question dealing kind of with the gears. So anytime it's the two gears, remember it was r theta equals r theta. That same idea could be r omega equals r omega, because all omega is take the angle theta divided by time, and since the times are the same, you can just set them equal to one another. The key to the question is, notice that this says the larger pulley rotates 25 times in 36 seconds. You have to make sure you multiply that by 2 pi because it should always be radians. So you have to multiply revolutions or times rotated around by 2 pi in order to find that answer. And when you do that, you should get 25 pi over 18, and that's the omega that's plugged in. I'm showing a little bit more work in how to solve for the other omega of the smaller pulley, but realize that you're really just going to multiply by a reciprocal on this left side because the radius times omega should equal the other radius times omega. And I did some simplifying, some multiplying through to find the answer. But realize it's the same idea as r theta equals r theta for the gears. It's just use omega instead. The key is still make sure you multiply by 2 pi for every revolution or rotation. The second question, thread being pulled off a spool at a rate of 59.4 centimeters per second. Remember, that's velocity or linear speed. Find the radius if it makes so many revolutions per minute. Notice here that the one is per second, the other is per minute. So you got to switch one of them. Doesn't matter which one you switch, but you got to switch one of them to make sure that it matches up. So remember, 152 revolutions times 2 pi to get into radians, and then I divided by 60 to get it into seconds. Now you could simplify that answer if you wanted. In the end, it's not going to probably matter because you're looking for a decimal answer anyway. So then V equals R omega. I have V, I have omega, now they're both per second. I just multiply by the reciprocal or divide by that fraction to the other side, and I should get a radius of 3.73 centimeters. It's centimeters because the velocity or linear speed was also in centimeters. The third question talks about a railroad track that has a certain radius. So here's the radius, 1,800 feet. It says the circular part is at an angle of 40 degrees. I need to multiply that by pi over 180 to get it into radians. And then find the arc length by S equals R theta. And I get just under 1,300 or about 1,250 not square feet, just feet. The issue with that is I need it to be in miles because I want miles per hour. Okay, the train traveling 30 miles per hour is the velocity, or V, for linear speed. Remember, linear speed equals r omega, which is what we've been using a lot. But in this case, it's s over t because we have the arc length. We might as well use it. But notice I had to divide that by 5,280 to get feet into miles. Once I have that, I multiply t to the other side and then divide by 30. Okay, that will give me the number of hours that something takes. If you need to figure out how long in seconds, you'd have to convert that by saying, okay, in 1 hour there's 60 minutes, and then 1 minute there's 60 seconds, so times 60 times 60. Again, a lot of the issues you're going to run into on this section, especially with your homework and tests, is the units. So you got to make sure that the units match up right. It's sometimes hard if you're not showing a lot of work to get partial credit on some things like that. So you want to make sure that your units are matching to look at those scenarios. I hope that these questions help when it comes to looking at some of your homework questions, especially with converting. Don't forget 1 revolution, 2 pi radians. If something's in degrees, times pi over 180 to get it into radians. Have a great day, everybody.